we're going to discuss a way to measure angles using something called a radian. Okay? So in a circle, we have 360 degrees to go all the way through that circle. Correct?
Okay.
Okay, you with me? All right. Now, that circle, as I go through, creates two things. It creates an angle here, down between this area. In this case, that angle is 35 degrees. So as I increase through this circle, as I go through the circle, that angle increases. Okay? And it also creates what we call an arc length. An arc length is this edge over here. In this case, it's in red, this piece of red over here. And as I increase through the circle, that arc length also increases.
Okay.
All right. So, and that arc length does depend on the radius. So you'll see if I make a tighter radius, that arc length becomes smaller. That red, it's red over here, but you can kind of see it in blue over here. And as I make my radius bigger, that arc length gets bigger too. Right?
Okay.
So I don't want to change that arc length. So we call this the unit circle. Unit just means one. So what I'm going to do is I'm going to just set this radius to exactly a measurement of 1. Okay, and then now we're inside the unit circle. So I'm just going to fix that to make it simple. Okay? Now as I go through, now the only thing that's going to change my arc length is how far through I go that circle. If I go all the way around 360 degrees, I will have gone the full circumference of the circle. And we can measure the distance around the circumference, the outside of the circle, by using the equation 2 pi r. But since the radius I fixed to be 1, the radius is 1, 2 pi times r, 1 times anything is just itself, so 2 pi r is just 2 pi. So if I go all the way around the circle, I will have traveled a distance of 2 pi around the edge. I would have gone 360 degrees as an angle in the center, but on the edge I would have traveled a distance of 2 pi from the equation 2 pi r. Okay. And if I go halfway around the circle, how far do you think I went? If all the way around the circle is 2 pi, how far do you think halfway around the circle?
1 pi.
1 pi, okay. And if I go a quarter of a circle, then that would be 1/4 times 2 pi, which I can calculate. Okay. So now I'm going to look at a circle very similar, and I'm going to cut a circle into slices. So for example, here is a half, cut it in 2 slices, 3 slices, 4 slices, 5 slices. I'm going to cut it into pieces. And then I'm just going to take a number of those slices. So no slice, 1 slice, 2 slices, 3 slices. Okay. So let's look at when I have 2/5. So I have 5 slices and I've gone 2 of those 5. Okay. And again, I form an angle in here. There's an angle there. And I form an arc length on the outside. Okay. So I have traveled 2/5 of a circle. So if I want to calculate how far I went on the outside, I can take 2/5 and I can multiply what it would be a full circle, which we said before would be 2 pi. So this will be the distance I traveled. Okay. And if I wanted to figure out that angle I traveled, then I can take that same 2/5 and I can multiply times 360, and that would come out to be 144.
Okay.
So 2/5 of either the distance on the outside or the angle on the inside. But these two numbers will always have to agree. If I, in the unit circle, in this special circle where my radius is 1, if I travel 144 degrees, it will always be 2/5 of the circle, and it will always be 4/5 pi on the outside. So therefore, I really don't need to always think about angles as degrees. I can also think about it as radians, because this will tell me the exact same information. So in engineering, a lot of times we use radians instead of degrees, because not only does it give you information about the angle, but it also gives you information about the outside.
Okay.
So this is a very common way to look at angles other than degrees. We call it a radian.
A radian.
Yeah.
Okay.